Of course, we've known for decades that traffic is harmful to the lungs, and diesel exhaust is a very important contributor to traffic. In recent years, the burden of this traffic and other outdoor air pollution has been associated with up to 7 million deaths per year worldwide, an astounding number. And recently, when appreciating that something needs to be done to decrease the harms of diesel exhaust, many agencies, including the EPA in the United States and others worldwide, have thought about the potential benefit of filters to remove these tiny particles, PM2.5, from exhaust. We therefore decided it would be important to study whether indeed those filters had the benefit that we hoped that they would. For years, my lab has been interested in co-exposures, knowing that when individuals are exposed to both allergen and traffic, the harm to their lungs is greater. Now, with the more recent question of whether the filter technology would actually lessen those harms, we did a study known as a crossover, where each individual would get both conditions, meaning with the filter and without the filter. Thankfully, with the support of AllerGen and a talented graduate student, Denise Wooding, we were able to publish our findings this year in a major international respiratory journal. In the Air Pollution Exposure Lab here at UBC, we tested 14 individuals in this crossover design, where they were exposed to allergen, allergen plus regular diesel exhaust, or allergen plus that diesel exhaust with the filter having removed the particles. Again, looking at our classic endpoints of airflow, which we measure in terms of FEV1, or the forced expiratory volume in 1 second. We then also studied methacholine challenge, which is a way to determine how twitchy or reactive the airways are, and cell counts, the classic cell counts, neutrophils and eosinophils, that characterize the lungs' inflammatory response to challenges. So as expected with allergen, lung function did drop in terms of FEV1, and we knew that would be the case based on previous studies. But to our surprise, when we removed the particles, that did not help. In fact, lung function got even worse. We were thinking that the particles were the problem, that by removing them, lung function would improve. But while we did remove those particles effectively by 94%, surprisingly, gases, and in particular nitrogen dioxide, increased by over 300%. And we think that's why, in that condition, lung function got worse. So naturally, this raises the question of whether these filter technologies are as beneficial as we'd hoped. And more broadly, it cautions us to consider, when there is a new technology, whether it's in fact as effective as it logically should be based on its characteristics. Now, this is especially true in susceptible populations. For example, asthmatics, such as we studied. They may be particularly at risk, and they need to be considered in our studies moving forward. Now, I do recognize that this does not lead to throwing out particle reducing technology entirely, because when combined with an oxidation catalyst, these particle reducing technologies can be very effective. It's simply that we need to look at each component and ensure that it works as well as intended.